afternoon or good evening, everyone. Good day, everyone. Wherever you are, you're hearing my voice. Today we move on to, like we did last time, we talked about the cross products. And this time around, we'll be moving towards vector differentiation and how do we use differential equation to solve some of the problems. What are the laws that governs them? So I would like to share my screen so that from there we can move on. If anything is not clear to you, feel free to ask question. Please,
okay, sir.
don't keep quiet, ask question. That's why you're here. Remember, that's why you're here. Okay, let's move on. Can you see my screen?
Yes.
Just 1 minute. So today we'll talk about vector differentiation. Vector differentiation. So when it comes to vector differentiation, what are the things do we need to know? We need to know when we have ordinary differential equation, how do we solve them? Please, like I told you, mute yourself for the purpose of this. Once you want to talk, unmute yourself. Just mute yourself so that you can enjoy my presentation, my teaching, and so on. So,
Mr. Thomas, I beg, mute your video so that it will stop distracting us.
what do
Okay.
you say? Hello?
Mr. Thomas, mute your video.
Okay. So are you okay now? Okay, let's look at it. Ordinary derivative of vectors. Ordinary derivative of vectors. That is, we said let's R of u be a vector depending on a single scalar variable, call it u. Then change in R, this means change in R over change in u, which is the same thing as R of u plus change in u minus R of u. You remember first principle, change in u. So you remember first principle? So it's more or less like when you have this particular R, let's say we have R in this way. This is our change in R is here. Then there is a particular line here to meet object O here in this way. And this is R of u. Then the both of them are what? R of u plus change in R. Change in u rather. So which implies R of U plus change in U minus R of U, where change in U denotes as increments in U. So when we say increment in U, I believe we all did calculus. Our knowledge from calculus, first principle differential equation, when you use first principle, is the same thing as when you say the R du equals to the limit, take the limit of change in U tends to 0. That is, our change in R over change in U equals to the limit of change in U tends to 0, which simply means R of U plus change in U minus R of U, everything divided by change in U. If the limit exists, that is, this limit, if it is exists, that means we have dr du. So now let's look at the space curve. Then from there, we now talk about the differential formula and partial differential formula. Then we now look at the rules. How do we solve them using the rules? Are we together?
Yes, sir.
Yes, sir.
Now let's look at it. Space curve. For the space curve, if in particular R of U if in particular R of U is the position vector R of U joining the origin O of a coordinate system, and any point x, y, z, then our R of U is equals to x of U I plus y of U j plus z of UK. So in this case now we have this, but the question is, remember, if our limit hold, that is our change of R, change of U equals to the R, the U exists. So we have the R, the U to be equals to, that is, differentiate each of them variable, will now be the x over the U I plus the y over the uj plus the z over the uk. Now that we have this, we can establish our differentiation formula. Let's look at the differentiation formula. Differentiation formula. We have differentiation formulas that says if A, B, and C are differentiable factor function of a scalar u and phi is a differentiable scalar function of u. Then, now let's look at it. Then, let's look at when you have A plus B, what happened? Then, number one, if I have the u of A plus B, what does it mean? It simply means the A over the u plus the B over the u. Number two, if I have d du of A dot B, it's going to be, now this one is different. How many of us still remember our product rule in differentiation? Do you still remember?
Keep one constant, differentiate one.
Yes,
then keep the other one,
differentiate one. God bless you. So it simply means A constant differentiate B du plus B constant differentiate A du. That's just it. Keep one constant, differentiate others. But number three, let's look at the cross. A cross B is more or less the same thing. A cross dB du plus B cross, or sorry, this is supposed to be this. The A du cross B. Don't forget, the position also matter in some cases. Number four. So when you have d du of phi of A, remember it's a scalar, phi will be d dA du plus d phi du A. Number five, when you have d du of A dot B cross C. So what do we have? We have A dot B cross the C over the U plus A dot D B du cross C plus the A du dot B cross C. This is very important. Look at the way I arrange it. Let it be well arranged like that. Because we will still need them, I'll be using them. Last but not the least, we have d du of A cross B cross C will be A cross B cross the C du plus A cross the B du plus C plus the A du plus B plus C. So in this case now, we also have the partial derivative. But the one of partial derivative, I'm thinking of not giving you everything now, but we can also, let's look at the example. Okay, let me just give us everything so that we can do both of them. And by the time we are applying the solving questions, you will appreciate it more. Let's look at the partial derivative. Partial derivative aspects. Partial derivative of vectors. So how do we solve this one? If A is a vector and we have this, okay, let's write. If A is a vector depending, see the difference between them now, on more than one scalar variable. Let's say that is x, y, z. For example, when you have e.g. A equals to A of x, comma y, comma z, then we can say the partial derivative of A with respect to x is defined as the A over the x equals to the limit, if it exists, goes to 0, A of x plus change in x, comma y, comma z, minus A of x, y, z, everything over what? Change in x. Remember, we only pick x. If it is y, you put change in y there. If it is z, you put change in z there. So the same thing happened to the A, the y will be the limits, change in y tends to 0. Now, if this one would be if the limits, these limits exist. So this will occur if the limit exists. That's when we have this, right? Similarly, the same thing happened to this A of x comma y plus change in y comma z minus ax y z. Don't forget change of y. The same thing applicable to z. Same thing applicable to z. Limits change in z tends to 0. A of x comma y then comma z plus change in z minus a of x comma y comma z over change in z. But we can also have higher derivative. For higher derivative, so we have the square a, the s squared equals to d dx of dA dx. So you can also have the square a, the y squared. It's the same thing. Is d dy into the a of the y. Take notes. I can have the z squared also. D the z, the a over the z. Okay, what about when I have different one? Let's say we have the square a, the x, the y. What will happen is going to be d dx of the a, the y. The same thing happens when you have the square y, the y, the x. Look at arrangement. The arrangement will be d the y of the a, the x. Please take note of that. If I have the square a, or if I have it to be 3, a, the x, the z squared. It's still the same thing. It's going to be d the x into the square a, the z squared, and so on. So the same rule also applicable. It also have their own rule. Let's look at the rule. For PD, partial derivative of vector. Partial derivative of vectors. So number one says d dx of a dot b, what we have is going to be a dot db over the x plus dA over the x dot b. Number two, A cross B is going to be A cross the B, the x plus the A over the x cross B. 3. You have the square, the x, the y, the x. Everything multiplied by d dot b is going to be d the y of d the x of a dot b equals to d dy of a dot db dy, the x rather, plus the a, the x dot b. So in this case now, if you open the bracket, what do you have in this case? We're going to have a dot the square b, the y, the x, plus the a, the y, dot the b, the x. So plus the a, the x, dot the b, the y, plus the square a, the y, the x, dot b. So, you know, these rules are there for us so that by the time we are solving some of those questions one after the other, we will, let me just stop from there so that I won't bug you with all the rules, all the laws, and so that you won't lose interest. But let's look at the example. Where do we apply this? Let's look at the example. Example 1. Example 1 says, given R equals to sine t I plus cos t j plus t k. They are all factors. They now said find A, the R, the t, B, the square R, the t squared, C, the magnitude of the R, the t, D, the magnitude of the square R, the t squared. You can see the difference. So, are we there, please?
Yes, sir.
Okay, go.
Yes, sir.
Solution. Now, let's solve this. So we have the R, the t. What does it mean? It simply means d dt of I sine t, which is our I, plus d dt of j, plus d dt of t. Right. So when you differentiate sign, what do you have? Hello? Calculus student. When you differentiate sign, what do you have? You have cos. Cos t I. When you differentiate cos, what do you have? Minus sine.
Minus sine.
J. And when you differentiate t, what do you have? You have 1. Okay. So we can boldly say that our dr dt is equals to cos ti minus sine tj plus k. Are we together? Because 1 multiplied by k is tk, right?
Yes.
Am I communicating?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. is still k. So we can proceed by saying that. So what do we need to do in this point? So we have, this is what they asked you to solve for A. Let's look at the B. B says the square R, the T squared. The square half the T squared is the same thing as the dt of what? The R dt. So don't forget, we already have the R dt up. All we need to do is just to put the dt there. Will be for cos t I minus d dt of sine t j plus d dt of 1k. So what do we do? So when you differentiate sine cos t, what do you have? Minus, which is equals to minus what?
Minus
Sine t I minus cos t j. Because when you differentiate sine, you have minus, you have cos t rather. Then when you differentiate this, you have plus 0k. Because when you differentiate constant, you have 0. So the final answer will be what? The final answer in this case will be
minus sine t.
Minus sine t I minus cos t j. So that is our d square r dt squared. So number C. C says we should do what? We should find the R, the magnitude of the R dt. Do you still remember the magnitude formula says A square B square plus C square, right? Do we still remember?
Yes, sir.
For those of us that are joining us for the first time, please try and watch the video. The previous video is there. Just try and watch it because of our time. Let's move on first. So at this point, you have it to be, we know our R, the R dt. The R dt is equals to what? Cos t I minus sine t j plus k. So which is the same thing as square root of both, each of them. We have cos t squared plus minus sine t all squared plus 1
K squared.
Right.
Plus k.
There's no k here. How? Why we don't have k? Should I tell you? Remember that anytime you have, when you find square of this, will give you 1. It's only when you have this, you have 0. You remember? So each of them, the square of I will be 1, the square of j will be 1, and those ones are gone. So you have it to be square root of, somebody is trying to talk. Musa's. Okay, so we have it to be cos t squared. So it's going to be cos square t plus negative times negative will be positive, sine square t plus 1. Do we agree with me?
Yes, sir.
So when you add cos square t plus sine square t is equals to 1, you remember the law? Therefore, we have 1 plus 1, which is equals to square root of 2. That is your answer. Any question? Any
No
question?
question for now
Okay.
from my side.
So if you look at D, let's look at the D. D part of it says the square R, the t squared is equals to the same thing as we know the square R is here. That's what we did in B, which is minus sine t I. So we have it to be minus sine t squared plus minus cos t all squared. So at the end of the day, you have it to be what? Sine square t plus cos square t, which is equals to 1 and is equals to 1. Any question? So now let's look at the question 2. Question 2 says, a particle, for those of you that have the past question, you can look at it. You will see some of those questions we're solving. They are there. Along a curve whose parametric equations are x equals to exponential minus t, y equals to 2 cos 3t, then z equals to 2 sine 3t, where t is equals to time. Where t is equals to time, the question says, A, determine its velocity and acceleration. B, no, at any time. B says, find the magnitude of the velocity and acceleration at t equals to 0. At t equals to 0. So in this case now, how do we solve it? What comes to your mind? Who can tell us? Remember, you are doing pen on paper, right?
Yes, sir.
So we have to speak now. So let's talk. Any problem? Yes.
We use the partial derivative to solve it.
We use partial derivative. Why?
Because he has more than one variable.
He only have one single variable, which is t. The rest is just normal position. Okay, let's look at it. Thank you for that contribution. Solution. Let's look at it. The position vector r, if I will call it r, of the particle is r equals to xi plus yj plus zk Remember, I defined this one first when we were about to start, right? So this is what leads us to the R, the T, the all true. But we cannot go ahead and solve this one. We know our X, we know our Y, we know our Z. Substitute those values there. Our R will become e raised to power minus ti plus 2 cos 3tj plus 2 sine 3tk. Any question? Any question, please? Remember, we have to find velocity and acceleration. And you know velocity is what? Is v, right?
Yes, sir.
So velocity we have v equals to the r, that is differentiation of the v dt, which is, we are using r in our own case, is the v, the r dt now. That is, we are differentiating our r that we are given, the position we are given, to be d dt of what? Exponential minus t I plus d dt of 2 cos 3t j plus d dt of 2 sine 3t k. So this is just the simple physics. That is, the differentiation of whatever you are given will be your velocity, right? So that's what we are using. So let's look at this. What's the value for this? When you differentiate exponential minus t, what do you have? Somebody's chatting. Sorry, what are you dropping your number for? Oshutokun. Ayinde.
Hello, sir.
Yes.
Yeah, we want to use it to create a group.
Which group again? For which course?
This course.
Oh,
Like
today is your
interactive
first
session.
time.
So, yeah.
Have you received any email from me?
No, sir.
Oh, okay. How do you get the link for the course?
Hello, sir.
You know, the link is always on our dashboard. All the classes.
So the link is there. The WhatsApp link is also there.
Yes.
If you register for this course, you will see the WhatsApp link there. Click on it and join the group. Right. You don't need to give anybody any number. The link is there. Just click and you will join. Except if you have a setting that you need permission, then give yourself permission and join. Is that okay? So,
yes, sir.
Okay, let's move on. We can differentiate this. When you differentiate exponential minus t, what do you have?
You give us minus exponential minus t.
Exponential minus t. Thank you. Minus exponential minus t. How do we arrive at that? Let me explain. Let me quickly digress a bit for the purpose of some of us that are looking, oh, how do they get it? Remember, when you have exponential minus t, it's like you have 1 here multiplied by t. Right. So, and it simply means when you are differentiating it, you are differentiating what is up. You have it to be minus 1 exponential minus t. So, minus times everything will be minus exponential minus t. So, if I have exponential minus 2t, I'm going to have minus 2 exponential minus 2t. Right. So, take note of that. That's just a digression. If it's not minus, it will still be positive. Thank you. So now let's differentiate the next one. So when you want to differentiate the next one, you have, I can take my 2 out as a constant by saying plus 2 is out. Then I differentiate cos. When you differentiate cos, what do you have? Minus sign, right? So I will have minus 3 sine 3t. So, and the last one will be plus
Minus 6.
You put it 2 outside. 3 cos what? Cos t. Okay. So if you write this one correctly, you have your dr dt to be minus, because plus times minus will be minus 6 sine 3t j plus 6
Plus 6.
cos t. Okay.
Okay.
So for acceleration, how do we solve acceleration? Acceleration means second derivative, you have to differentiate the velocity. Right. For acceleration, for the acceleration, we have to differentiate the velocity. So if you differentiate the velocity, what do you have? It will be a equals to d square r dt squared, which is the same thing as minus or d dt of minus exponential minus t I minus d dt of 6 sine 3t j plus d dt 6 cos this is supposed to be 3t, right?
Yes, sir. There's supposed to be 3t there.
Thank you. So we need to differentiate it again. If you differentiate it again, what do we have?
We have
Exponential.
positive.
Exponential minus t.
Okay. Do it in your note. Let's see. So what do you have?
have exponential minus t raised
You
to the
can't get
exponential
minus
raised to the
again.
power of minus. Sorry, I say exponential minus t I minus 18 cos 3t j and minus 18 again
No,
sine.
no,
When you differentiate cos, you have minus sine. So
no, no. I'm not talking from the beginning. You said exponential minus t.
I say e raised to the power of minus t.
Oh,
When
okay.
that's
Thank
for
you.
acceleration.
Yes.
I
E raised to the power minus t. Yes. I.
minus, yes sir,
Go ahead.
minus 18 cos
Let's do
3tj
it one by one. 6 in brackets. 3 cos what? 3t.
3t. So
Plus
plus
6 in brackets minus 3 cos 3 sine t.
yes
3
sir,
sine 3t. Okay. So which is going to be what? Exponential minus ti
yes sir,
minus 18 cos 3t j
yes sir.
minus 18 sine 3t k. Any question? Are we all the same page?
Yes, sir. I have the same
Then
thing here.
the big question says what? He said at t equals to 0, the r, the t is equals to what? At t equals to 0, let's go to the r, the t. Here is the r, the t. Put 0 and everywhere. You have it to be minus exponential 0 I plus minus six sine 3 of 0 j plus 6 cos 3. Is it cos? Cos 3
Yes sir,
of 0.
yes sir,
Okay, thank you. So we have it, this one to be 1, negative 1 I. This will be plus 0. Everything here will be 0. J. Now we have cos 0 is
6,
1. 1 multiplied by 6 will give you plus 6.
6,
So our the r, the t will be what? The negative 1 I, or will be I, negative I, sorry.
Minus I plus 6k.
Minus I plus 6k. God bless you. Yes. So can we do the second one? The square r, the t squared. The square r, the t squared is anywhere you see 0, anywhere you see t, put 0. You have exponential 0 I minus 18 for 0 j minus 18 sine 0k. So at the end of the day, you have 1 I, or let's just say I. so that you understand. You know, this place will give you 1i minus 18 of 1j minus 0. This will be I minus 18j. That's all. So what do we have?
Yes, sir. Same thing, sir.
Same thing, right?
Yes, sir. I minus 18J.
Now, the question proceeded saying, can you read the question? Somebody should read it for us. Or you don't write it, or you are just watching the video.
Yes,
So
sir.
he said a particle moves along a curve whose parametric equation are as follows.
Okay.
Yes, S equals to E minus exponential T. Then Y equals to 2 plus 3T. Z equals to 2 sine 3T, where T is equals to time.
Okay. You now said determine its velocity and acceleration,
Acceleration.
right?
Yes, A.
So at any time,
Yes.
then we now ask find the magnitude of the velocity and acceleration at t equals to 0.
T equals to 0. Yes.
It simply means the velocity and acceleration, you have to put t equals to 0. That's what we just finished.
Okay.
That's what we did at t equals to 0. Now we need to find the magnitude of the velocity. As we all know the magnitude formula, we did it the other time.
Okay.
You understand the question now?
Yes, sir.
So the magnitude means the r, the t, at t equals to 0, which is the same thing as square root of, we know t equals to 0 to be what? What do we get for the r? We have negative 1 squared plus 6 squared. Yes or no?
Yes.
Yes, sir.
Yes.
So we have it to be 1 plus 36 equals to what? Square root of 37. So can we do the second one by ourselves? So it will be magnitude of acceleration at t equals to 0 will be what? Square root of, we have 1 squared
1 square
minus 18
minus
squared.
18 square.
What do you have? Which is the same thing as square root of 25 times 13, which is the same thing as square root of 25 multiplied by square root of 13. 5 root 13. That is what you have. Any question? Does it make sense?
Yes, sir.
Okay. Okay, let's look at this. They can also ask you to prove those laws that I stated. They can ask you to prove them. How do we prove? Let's look at one of them. Then you can go ahead and prove the rest by yourself. Because as if A and B Sule, Mute yourself. Are you in the market? If A and B are differential function or differentiable function of scalar U, prove that A d du of A dot B is equals to A dot dB du plus the A du dot B. I often see this question. Then they can ask you d du of A cross B equals to A cross dB du plus the A du cross B. Okay, let's solve this problem. Solution. Let's A equals to A1 I plus A2 J plus A3 K. Then our B also equals to B1 I plus B2 J plus B3 K. Now, remember when you say dot, it simply means component by component.
They're calling you now.
Hello?
Yes, sir. Go ahead, sir.
So, component by component, that is I to I, J to J, K to K. So d du of A dot B would now be d du in bracket M dot A1 dot B1. It will now be A1 B1. Now, anytime you remember this, let this be about at the back of our mind. I dot I is equals to 1. I dot J is equals to 0. I dot 1 is 1. 1 multiplied by everything is still everything you have here, identity. So we have plus A2 B2 plus A3 B3. Now, we need to now differentiate them. Remember, you differentiate one, you hold one constant. In this case, let me pick this. I'll differentiate B1 now. I'll hold A constant. I'm going to have A1 the B1 over the U plus A2 the B2 over the U plus A3 the B3 over the U. Then plus, remember I only did for A. I will do the same thing for B. Will that be plus, in this case now, the A1 the U B1 plus the A2 the U B2 plus the A3 the U B3. Do you agree with me?
Yes, sir.
Now, remember, what do I say from the beginning? I said, let A be this. It simply means A1 I, A2 J, A3K, they are all A. If I call them A, I'm okay, right? Hello?
Yes, sir.
So if I call all of them A, just look at it. If I said A dot, I'm doing this now. A dot dB du. Do you agree?
Yes, sir.
Everything that I underline is A dot dB du because this one is A, this one is A, this one is A. If you add all of them together, they are A. If I add B, B1, B2, B3 together, they are all B. So they are all have dB du plus the A over du
du
dot what?
B.
B,
Dot B.
which is same thing as D du in brackets A dot B. I've already proved it. That is what they asked us to prove. Does it make sense?
It's making sense, sir.
Okay. So let's try as much as possible to lay our hands on different questions and solve them. For the second, yes, any question? Okay, let's solve the second one that have a cross. Because of the cross is different. B, the B question says, D du of A cross B. Don't forget, we know A1, A2, A3, they are the same, but cross means it is talking about matrix form. I, J, K. What is A? A1 is I, A2 is J, A3 is K, and B1, B2, B3. You remember the way we used to find determinants using the theorem of determinants to solve this problem. So for us now, but don't forget you have D du outside because everything must be D du. The cross already is inside. So if everything will be D du, so how do we split them? That means you differentiate one, you hold one constant. Now let's see the same thing. So it's going to be I, J, and K. So if I hold my A1 constant like I did when I was doing this, remember I hold A constant here. So I'm going to do the same thing. A1 will be constant. A2, A3 are constant. Then I will differentiate the B1 du, the B2 du, and the B3 du. Plus, can you please mute yourself? If you know you don't mute yourself, just mute yourself for the purpose of others. Thank you. I, J, K. So I will differentiate the AI, the U, then B1. The A2, the U, B2. The A3, the U, B3. So what do I need to do in this case? I need to first of all solve the first one and the second one and match them together. For the first one, if I want to solve this, remember the way we used to solve determinant plus minus plus, right? It's the same thing that we're going to use here. If I'm picking I, let's say I'm picking I, the I that I pick will be positive. The row 1 that I belongs to will paralyze. The column 1 will also paralyze. It will remain A2, A3, the B1 du, sorry, the B2 du, and the B3 du. Minus J. We are picking J now. We will release this one. We pick J, which is minus. So if you pick J, what do we have? The row will be paralyzed. The column will paralyze. The row will also paralyze. Remain A1, the B1, the U, A3, the B3, the U, plus K. Then we pick K now. If you pick K, this one will paralyze, the row will paralyze. It will remain what? A1, the B1, the
The
U,
B1, the U, A2,
A2, the B2, the U. So what do we need to do? I will be, you just cross multiply this, multiply by this minus this. So it's going to be A2, the B2, the B3, the U, minus A3, the B2, the U, minus J, this multiply by this, and this go with this. A1, the B3, the U, minus A3, the B1, the U, plus K. We have A1, the B2, the U, minus A2, the B1, the U. So, at the end of the day, we all discover that when you open up everything at the end of the day, if you open it up, you will now collect the like times. At the end of the day, you will have at A cross the B, the U. Do you agree with me? Because remember, all A, whether A1, A2, A3, whatever you call yourself, you will see you are still A. Do you agree?
Yes, sir.
And all the differential, they are still the B, the U. So therefore, we can boldly say, if you open, you don't need to expand anything. At this point, you can conclude. And you do the same thing to this one. Remember, if you are doing this one, the B, if I pick, let's just pick one. We only pick one. This will paralyze, this will go. It will remain the B multiplied by this. And this multiplied by this. And I know the function where it's supposed to be. If I say I is equals to, will be what? The second one that we said will be
B2.
The A, don't forget, it's going to be the A squared, the A2 over the U. B3 minus the A3 du B2. That's all. Minus J and so on. When you open it, this part, the first one alone gives me the A over the U B. Do you agree?
Yes, sir.
So if I have this, then I can conclude that A cross the B, the U, plus the A, the U, B is equals to G, the U of A cross B. Any question? Any question, guys?
So we didn't finish the write-up. Let's finish it.
We'll go and finish it at home.
You
Let's
don't
finish
worry,
it.
I will send the video to you.
Yes, so that
You will finish it. So they will ask you to do it the way they can. All these questions we are solving, they are more or less some of our questions we do every day. And so let's take note of them and let's use it to prepare for ourselves and look at it. Also work with the past question and see some of those things we've been solving. Any other question?
and the one you gave us one the last in our previous class.
But you did not submit.
Okay, I thought you said you review it in this previous class.
But have you solved it?
I tried to solve it, Sha.
Go and solve it. Watch the video. Others, go and watch the video and make sure you solve it. It's just for one of the questions.
Okay, I will snap and submit it.
Yeah, you can send it to my personal chat. I will look into it.
Okay, sir. Okay, sir. Thank you very much.
Question?